All right, so part two of our introduction to JavaScript and Python is about, we were talking about data and variables and different data types, and now we're talking about the logic, the algorithm, and a little bit of what's called functional programming. This is a much deeper well. There's a whole paradigm called functional programming that we're only going to dip our toes into, but we're going to see it in Python, JavaScript, and we'll see a lot of pieces of it. So this is about how do I transform data? Once I have logic to say calculate a user's age, how do I reuse that logic? And how do I control what my program does and when? And we're going to see patterns in our code that we can use. And we're going to see how we can use things like looping and conditional logic to help us build well-designed programs and build up these building blocks. So we're not going to dive too deep into syntax, but we're going to understand like the how and the when of it. And first up is comparison operators. And comparison operators are about checking if one thing is like another. Right? And in JavaScript, for example here of an age of 18, there's a number of comparisons I can do. I can check, is this person greater than 18 years of age? I can check if this person is less than 18. I can check if this person is greater than or equal to 18, right? Which is pretty important. 18 or over. If, say, we're figuring out how old you have to be to rent a movie, well, here you would have to be 19, at least 19. So this is a little difference, but this greater than or equal to versus greater than is super important. And let me go ahead and run this code, and we'll see that comparisons produce Boolean values. So what you might often see is you do the comparison and assign the output of this, because when you run this code, it gets assigned to this variable on the left, right? Over here, this returns a value. What gets returned gets put over here on the other side of the equal sign. The same thing is happening right here, except what gets returned is getting passed as an argument into this console.log function. And so if I print is of age, we should now see a Boolean. And Python works very similarly, so I'm just going to make one demonstration here with age of 18, and we'll print if age is greater than or equal to 18. And I just want to check in to see if folks have any questions or stuff that you're curious about. Cool. Comparisons are used for all sorts of stuff. You will be writing this all the time with code, filtering data, all sorts of other things. The next tool in the toolbox is the classic if statement, right? Choose your path. And programming, by the way, software engineering and tech is really sort of like a choose your own adventure book career. So I think this diagram is particularly appropriate. The beauty of choice is we get to choose. The challenge of choice is we get to choose. And we have three different constructions here, if, else if, and else. So let's talk about these. So actually, let me move up a bit. So this is an important point right here. And actually, I would like someone to read this paragraph. Maybe someone who hasn't read yet today could volunteer.
I got it.
Thank you, Cami. Go for it.
Conditional statements allow a program to branch execution based on conditions. They answer the question, if this is true, what should happen? Think of yourself in the middle of a workout in a busy gym. You want to do a leg exercise, so you formulate a thought, in your head along the lines of, if the leg extension machine is open, I'll hit quads. If it's busy, I'll see if the leg curl machine is open to hit hamstrings. And if neither of those are open, I'll just squat since there's always a squat rack open. You do these conditionals in your everyday life. Now we apply them to programming itself.
I was totally muted there. Thank you. Thank you, Cami. Now, the reason I got so excited about this is because it touches on one of the most important things in programming, which is, let's see if I can make the font size big enough because I want it to be even bigger here. Um, I'll just kind of put it over here for emphasis. Problem solving. As cheesy as this sounds, we solve problems all day, every day, and we come up with plans, right? We come up with formulas, we come up with approaches, we come up with algorithms, right? Or rules or processes. And the if and the else statement are like the bread and butter. And programming is all about you get a fuzzy problem like how can I get the most workouts in at the gym? And you could imagine someone giving you a coding problem that said, you have X amount of time and Y machines, and three of them are busy at this time. How would you write a program to maximize your workout? And the answer is to always try and think about it like you would in the real world and how you would go about it, and try to write down what you would do in plain English. And once you have that idea, then you start turning it into code. I think a lot of people jump right into the coding without the thinking, or they call it the pseudo coding. And that's where you guys are going to learn how to think through problems before tackling the code, right? So I realize that the example is kind of simple, but that's why I get so excited about it. And so here we don't yet have a problem to solve, right? Just to use an example here from here, we have a score. We're saying, hey, if the score is greater than or equal to 90, we're going to do something. And by the way, when you're writing code, do it in little bits. Once I've written this much code, the beauty of it is this is enough code that I can run. And I might have a typo. I might have made a mistake. I run my code like every 3 lines of code. I'm running code. I'm running code all the time. I use software so that whenever I save my file, it runs the code again automatically, so I don't even have to think about it. And now that this first if statement works, right? Because maybe I forgot this, maybe I want to test it and say, you know, 80 or something and see if it's right or not. Now that this works, let's add on the next bit of code and let's do else if score is greater than or equal to 70. And note that you can put the else if over here on its own if you want. You can put it over there if you want. It's really up to you. And then finally else, right? Now, the order of this matters, right? Because by the time we get to here, I know already that they didn't pass, or else this code would have run and we wouldn't have gone into the else statement. And I know they didn't get a pass with honors. And so that's the beauty of if else statements and conditional logic. If this is true, we know this code runs. If this statement in here is not true, right? So really, whatever is in there needs to be able to be reduced down to a Boolean. And that's why we have a comparison operator in here. Now, let me ask you all a question, and this is a JavaScript thing. What do you think the output of this program will be, of these lines of code right here? Someone's got to give me a guess. There's only 3 options, right? It's got to be this, this, or this. There's zero negative consequences here to getting it wrong. Someone, Erica, I saw your hand go up.
Is it pass with honors because the Boolean will be true.
Yes. Um, Good job. And the one thing I want to add is this isn't quite true. JavaScript has a weird special term that we call truthy. Um, in JavaScript, for better or for worse, the language will convert certain kinds of variables to true. This is truthy. Any sort of number, I believe, is truthy. And let's see if that's true. Yep. By the way, why did I see both of these print statements just now when this evaluated to true in this first if statement?
Because it's being interpreted from the top down.
Yeah, right. This is not an else if. This is not exclusive. Sometimes you want multiple ifs, if this is true and this is true. Sometimes you want it to be exclusive. So this is truthy. Unfortunately, in JavaScript, 0 is going to be falsy. We're not going to see this printed out. And in JavaScript, we're not going to see this empty string because JavaScript is weird. Python is not like this. Python does a much more sensible job. In JavaScript, I think I'll just pause there because I think I've kind of hammered the point home. In Python, we also see that this code is much friendlier to write. Right? And let me put that there. And in Python, instead of else if, we use the elif command. And now I can go ahead and run my Python code. Conditionals we're going to be using all the time. And there's a nice Venn diagram here that helps us think too about what category things fall into, right? Because we might want to check multiple conditions, like say for age and if someone has ID, right? So if someone is old enough to drink, then we fall into the overlap of this Venn diagram here. And let me just comment out this code here. And let's write this JavaScript code out and we'll talk about it. And in fact, we have a typo in the Python code because that's an uppercase true or in the code. And looks like we already have age, so I can just reassign it. So what's the problem that this is trying to solve, by the way? Like what in the real world or in the world we're creating, what is this code doing? What's the point of it? Why was it written?
To figure out what to do next.
Yes, but I think I'm asking an even simpler question than you guys are thinking about. Like, what does this code tell me about the person, whoever has the age and ID values? Like, for instance, if we had, let's in fact mix this up with, we've learned about objects. So let's say Bob has an age and Bob has an ID, true. If I'm using this code to figure out something about Bob, what am I figuring out? And let me answer it because I realize I made this a bit of a question, right?
If he's old enough to drink.
Exactly. Exactly. Like I said, I apologize. I didn't mean it to be a trick question on purpose. Where I wanted to go with this is as programmers, writing the code is the easiest part of the job. They might say, all right, we need you to write software to check, is this person old enough to drink? And I might ask, okay, what are the rules? And they might say, well, they have to be 21. And then I might say, does that mean they exactly 21 is okay, or you have to be 22? And they'll say, no, at least 21. Say, okay, cool. at least 21. And we won't even worry about people's whose birthdays are at midnight. And then I might say, well, what else does this person have to be able to do to walk into a bar and drink? And then they might say, well, actually, that's a good point. They need an ID, right? So these are my requirements. This is my problem I want to solve. And now I get to create a universe to help solve this problem. And I decide, all right, how do I want to structure my data? Well, my information about my person, I'll put in an object. We'll talk about functions in just a bit, but we'll write our logic. And the way to solve this problem is you break it into parts. And I've kind of done some pseudocode right here. They need to be at least 21, right? And they need an ID. So if they're at least 21, excuse me. There we go. If they're at least 21, then let's go ahead and console log and say they can drink. Now, is my program done? Have I met all the requirements? No, not at all. But when you're writing code, and it would help, I have a problem here. I forgot that this age is not the same as this. So let's try age equals bob.age, just so that this way my code looks the same as the example. And let's see if that does it now. There we go. I don't know what this age value was somewhere up in the previous code, but I forgot that this variable was defined already, right? If I was just doing this on my own, I would have just done bob.age. But this way, the example looks like what we're seeing in the curriculum. So this is called iterative development. The way you solve a problem is you break it into smaller problems. And what you'll learn with coding is you'll be shocked how small you need to break problems into. I can promise you, for the next 15 weeks, every time you're writing code and you're struggling to figure out what to do next, you're probably not breaking it up into small enough parts. And the most important thing is run your code all the time, because I could make typos, I could make mistakes. If I do this, and maybe then I do, has ID, and I write all this other code, and I say else if, age is greater than or equal to 18, and I forget some code there, and I do console log. They are an adult, but can't drink. And then I say else console, this person is a minor. So I just wrote like 7 lines of code with 4 different errors. When I run this code, we absolutely can solve and debug this. And we just do it one step at a time, right? And I'll show that in just a second. But the point I want to make is if I've only written 2 lines of code and I run my code and I get an error, it's really easy to know where the problem is, right? I now, though, have like 7 lines of code and I'm not actually sure what code is good, what code is bad. So if there's one thing I can emphasize is code is always in one of 3 states. Good, which means it runs, it does what I expect, it has no errors when it runs. Bad, which means it does not run, does not do what I expect, or runs with errors. And I don't know. And what do you all think the I don't know category of code means? And this is a trick question. I don't know means I haven't run my code. I have no idea if it works or not. So here's another trick question. How do we know if code works? Can I tell just by reading it?
We running?
No.
Yeah, we have to run it. So obviously you can read code, and if you're skilled enough and if the code is straightforward enough, you can figure it out. but code gets too complex. And if Amazon is, paying software engineers like 170K and they pay them an awful lot more than that, if we go to this salary site levels, FYI, and we look up Amazon and we look up where do they have the software engineer roles? Let's see here. Amazon software engineer. So levels, FYI, is where like big tech employees go to anonymously share salary information. So let's do by company. Let's go by Amazon. Here we go, software engineer. So the reason everyone wants to get into big tech is because they make a lot of money. Entry-level software engineer is looking at almost 180K, 134K plus about 40K in stock. After about 2, maybe 3 years, you're in a position where you could grow from L4 entry level to L5. Your salary then almost doubles by 100,000 and then even more. Now, the reality is that these big tech companies are extremely challenging to get into. The interview process is challenging. Unless you're coming out of a top CS program for a lot of software engineers, including me, going to one of these companies is like a mid-career move when someone goes to like a really good grad school. Like I might have to spend a couple months preparing for the Amazon interview. So that's just to kind of set expectations that it's 100% doable, but is usually not an early career move. But the point that I want to make with this is if Amazon is paying me 180K to write code, my job isn't to tell them that it works. My job is to say, I know that it works and I can prove that it works. Right. And that's what software engineering is. And we do that by running code. And tomorrow we'll learn about testing, which is also a part of that. So I don't know means I haven't run my code, which means I have no idea if it works. Because the only way to know if it works is to run it and see what it does. And which state of code do you think is the worst possible state for your code to be in? Good, bad, or I don't know. And this is another trick question. Well, it's not good, right? So which is worse, bad, or I don't know?
I'd say I don't know.
I don't know. Yeah.
Yeah, exactly. This is the worst possible state for your code to be in. Your most important job is to always keep your code in either a good or a bad state. I cannot emphasize this enough. If you, and this took me years to learn and from working with a lot of mentors who were really good and seeing their workflows. One of my mentors did like machine learning stuff at Google, and he was like, if I don't run my code every 10 minutes, I get nervous. And that was when I started to really get serious about this. If you all start getting in the habit of running your code all the time, your life will become so much easier, right? Because this code, we can debug this, right? And we're going to do it now. If age is greater than 21 and has ID and there's an unexpected signifier age, except the problem here is this unexpected identifier syntax error is not telling me what the real problem is because the real problem is with the syntax itself that I forgot a parentheses. So to fix this kind of error, I can't just look at the error and know what the answer is. I have to be able to look at the code and think about it. And if I have like this much code to look at, that's a lot harder than if I only have this much code. So write code in small chunks. Right. And now if we go on and we run it again, we see another syntax error, right? And this is on line 55 over here because, but note that the error is being thrown on 55, line 55, right? Is where it says it's coming from. But the actual problem is the curly bracket I forgot up here on line 53, right? So again, if I had run my code and the only code I had added was this, that error is a lot easier to fix than if I'm looking at all this. So we continue debugging. We see another syntax error. This one is now on line 53. And it looks like I've forgotten something because I've been talking about all this stuff. I've fallen prey to my own bad advice because we now have this and this. So another trick I like to do when debugging And this is, I think, actually the best debugging technique is get rid of stuff by commenting it out. So I'm going to comment out code until my code is good. Because I don't remember what caused this error, even though I was the one who made them. And now I get reminded, oh, I deliberately named this variable wrong, and this variable doesn't exist, right? So the more you comment out code when you're debugging, the easier things become. And so now I'm going to do has ID equals Bob.has ID because I want to follow the same pattern. Now that I've done this here, I should do it here for consistency. And we'll fix this to be like that. And now I'll run my code. And now I know that this code is good. This is great, right? I now know that I have code in a good state. Now I'm going to uncomment just this chunk. I see there's a red squiggly. And you know what? I'm excited because I'm about to run my code and I'm going to know that some of it is bad, which is great. This is progress. Bad code is good. It's progress. So we have our syntax error, else if age is greater than equal to 18. And I actually don't know. Actually, now I do know what I did wrong here. Can anyone tell me what I did wrong that's causing this error? I'll give you a hint. It is on this line and it has nothing to do with this curly bracket. So
It's supposed to,
oh, go ahead.
is it supposed to be else if, not elif?
Yeah, I confused my JavaScript and my Python. So when you're writing code, it's real easy to get tunnel vision, right? It's real easy to get tunnel vision. And in fact, one of the best debugging strategies is called rubber duck debugging. And the idea is the joke is you find a rubber duck, you put it on your desk, and you explain to the duck what your code is supposed to do. And then at some point by talking about it, you see the error. Because I can stare at a screen all day long, and I'm not, it's easy to miss that kind of stuff. The other way to rubber duck debug is to do it with another person, obviously. Sometimes the rubber duck is better, sometimes the person is better. So let's run our code again. Now the code is working, right? It doesn't seem to be throwing an error. And now I'm going to fix this. And in the interest of time, I'm just going to fix this last console log. And now we should have my code running. But how do I know that my logic is correct? Well, I don't know because I haven't tested it. I know that this works, but what if this stuff is screwed up? So let's change Bob's age. Let's just leave that there for a moment. And let's just say age is 18. And let's run it and see how it works. And that happens when it should. And if I change this to 17.5, that's what I want to see there as well. Right? So again, think about writing code and running code. It's a bunch of experiments. And the more you get comfortable with that, the easier writing code is. In the interest of time, I am going to move over this Python example as it covers the same thing. There will be multiple conditionals. And in fact, we've kind of seen that in action here already, right? If I change has ID to false, this would not happen. Let's move on and let's talk about looping, right? Let's talk about loops and iterations. And let me do a bit of commenting out here just so we don't have too much stuff printed out. And I've been writing a lot of Python code or a lot of JavaScript code. So I think let's switch. And this next example I'll do in Python. And I just want to pause and see if folks have any questions before we move on. Okay, cool. So looping. This is also called iteration, right? And the most straightforward way is I want to loop or iterate through a list. And Python makes it really easy. I don't need to worry about indexes or anything else. Expected indented block, I see. So this is a Python thing. This is actually good to point out. In JavaScript doesn't care if you indent your code or not. Python does. That actually breaks the language. So when I commented these out, the error that these red squigglies that I see, and if I run this Python code, the error that we will see, actually that does work. I guess it's just unhappy with it. It's telling me it's not a good practice. Python has a special keyword called pass, and it's just an empty placeholder that tells Python nothing should be happening here. This else if is empty on purpose. So in fact, rather than have that there and have the code be confusing, we're just going to comment out that whole block. And now that bad syntax goes away, and now we can run our Python code nicely. There are other ways to do looping. In JavaScript, that loop is, they call it a for of, and we actually have to create a variable inside of it. And in Python here too, we are creating a temporary variable. Right, I'm creating a temporary variable, the color, and the value of it gets changed as the loop moves through each item in that list. And I could do all sorts of stuff here, print, we could print looping. We can put as much as we want in there, though I'm not sure why my print statement did not print. And it's because I did not save my file. And now we see our looping statement. Sometimes when you loop, you need the position of what we're looking for. In JavaScript, it used to be this was the only way to write a loop. And let's actually make this a const because we're not going to add values to this. And so I might do, I'm creating a temporary index or counter variable. I'm setting its value to 0. I'm telling my for loop we're going to keep looping until the value of I becomes equal to the number of items in my array of colors. And every time you finish a round of the loop, increase the value of I. And this is useful, say, for things like, saying, how many bottles of beer I want. Though that's not what this program would do. And in the example here, we see that in this console log statement, if I pass it a couple arguments, and here I'm accessing the ith element, right? So the first round, this would be colors 0 the first time through the loop. Then when I is 1, we're printing colors 1. Then we're printing colors 2, which is green. And I made a mistake here. I forgot that I want this to be a tagged template literal. I did not follow my own rule. I should have ran this code after the first console log statement before writing the second. But luckily, there's still only about 2 lines of code there to tackle. I just want to pause and check in and see what questions folks have here, or anything that people are curious about.
I am struggling with JavaScript iterators. It is like, it hurts my brain. Okay, so
Yeah, let's break this down.
yeah, I'm like the second one, the console.log, the second console.log, like how is that working?
Yeah, great question. So let's put all of these off to the side for the minute and we'll break this down. So let's just console.log I. And this is a great question. And I think the way to tackle this stuff is always simplify and then build up in pieces. So what's happening here, and you're right, there's a lot happening inside these curly bracket, these parentheses. we're using JavaScript's for statement. Just like how in an if statement, the stuff inside parentheses kind of gets evaluated. That's what's happening here. And then the curly brackets in programming are what's called a block. And a lot happens here inside this loop. And the secret is in the semicolon, because the semicolon is how JavaScript tells that we are at the end of a line of code. So our first line creates a variable named I, and we set it equal to 0. Our second line, and this is a little special because this is the for statement knowing what to do with this line, compares the value of I to the length of colors, right? And as long as this is true, we keep looping. Once this evaluates to false, the for loop will stop for us, and this increases the value of I. Now there's a little bit of magic here because, again, the for construct knows what to do with these things, but that's how we can break it down. And because it's the semicolon that matters in JavaScript, if I really wanted to, though you probably wouldn't want to write your code this way, you could write it like this, I think. Yep, and that works just fine, right? But if I get rid of that semicolon, then we are in trouble.
Okay, so
An identifier.
when you do the length, it doesn't have to be equal to the length. It's just as long as it's less than the length.
Exactly.
Okay,
So
because that's in like I have Python like permanently etched in my brain, and I'm like, I feel like if you do the length, you know, like the range in Python, it's like that, I'm assuming. But with that, you have to like go one less. So
right. You absolutely have to always pay attention to thinking about length and how much of it. And so that's an excellent point. And that's also, by the way, why I started this value of I at 0. And we call this 0 indexing because this arrays and things start at 0. If I had set I equal to 1, the scenario you're pointing out would indeed happen. We would miss a color, right? Because if I run
yeah,
this,
it would start in blue.
yeah. And in fact,
Because
now
that's
let's,
the
yeah.
yeah.
And in fact, speaking of building stuff up, let's add our next console log where we're now printing those out. And we see because the index is at 1, it starts with blue. Then it moves on to 2, which is green, right? While if this was 0, we see red, blue, green. And now that we've done this, let's take this last console log. And now that we've broken this down, all that's happening here is this console.log function can take multiple arguments. And a function, when you call a function, you do it with parentheses, right? This will execute this console.log function. However, for this particular kind of function, console.log, we just won't have anything interesting happen because the whole job of this function is to print stuff to the screen and it prints whatever arguments we pass in. So usually, we see messages like this, but you can actually pass in, you can pass in arrays, you can pass in other things. And because sometimes we want to print out a whole bunch of stuff, JavaScript has made it so if I pass in multiple arguments, it prints out both of those things. And we see right here, we see that colors dot is printing out multiple things. Right, it's printing those two things with a space between them. JavaScript syntax, excuse me, absolutely is kind of funky and kind of harder to learn than Python, I would say without a doubt. Yeah, Cami, great question. Thank you for asking that because I think that's a great thing to break down and for us to dig a bit more into like the guts of how the language structure works.
Yes,
What other
thank you.
questions?
That was helpful.
Absolutely. That's what I'm here for, 100%. And by the way, folks, this is exactly how you want to break down code. You are all going to encounter a lot of code that feels a little magical. It's not going to be possible to dig into all of it, but please try. Because this is the level of understanding you want to have where you can explain exactly what each line of your code is doing, right? Because again, if Amazon's going to pay me like 170K, that's a very reasonable request for my employer to have about me doing my job. And in a technical interview, that's the level to which you will be asked about the code that you write. It will slow you down right now, but if you do it now, it will speed you up by week 7. So when you write code or when you read code or when someone is demoing code, please ask questions about any part that you're not 100% on. And that's why we also have people talk about it. What other questions do folks have or people are curious about before we move on? Okay, cool. Let's keep rolling. So we saw this JavaScript example with index, and I'm going to put it back into the format that's a bit more normal for it. With Python, and I'm going to comment this out just so I don't have more console logs in the future. With Python, getting an index is a little funkier because the language is just a little different. We have to use what's called a range, as you were saying, Cami. And we're going to do for I. In Python, we often, this temporary variable, we name it IDX, which is short for index. And we have to use a special Python operator called a range. And if we look at the wonderful VS Code autocomplete, we see that it tells us a bit about what a range does. And there's some stuff here that we don't understand yet. It returns an object that produces a sequence of integers from start inclusive to stop by step.range, blah, 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 blah. So there's a lot of stuff here that's more complicated in terms of how Python works. But if I read this, I get a sense, all right, it gives me some numbers in order. All right. And that's kind of where you want to start to just get from 0 to 1 in terms of kind of understanding on this stuff. Now, when I'm using this range function, I have to pass it some arguments. I have to tell it how many numbers I want it to produce. And we're going to use this length function in Python that gets me the length of the number of items in this colors list. We'll put our bracket at the end there. And I'm still seeing a red squiggly, so I think I may have something wrong in my code. Oh, it's because, again, I keep forgetting. Yeah, right. So you have to be careful when you see the red squigglies. That code would have run just fine. That's VS Code helping me with syntax. And in this case, the red squiggly was from a syntax error here, but makes it hard for VS Code to know there because Python doesn't like it if you have a loop with nothing in it. So now we can print our index and let's print the color at our index. And if I run that code, we should see the same thing happen. Both of these tools are useful. You can go even deeper down this road. I'll just show one of these examples. I'll show the Python example. The JavaScript example. Well, I'll just code both of these. They get a little fancier. But I'm not going to go too deep into this just to make sure we have enough time to cover everything that we need to. So this is where, again, you just want to be writing lots of code and a lot of these sort of fundamental programming problems we give you, because there's lots of cool features to these languages. Like I want to print out not just the index, but also maybe the color. So if I do a for loop in JavaScript, and I'm using const instead of let, but it doesn't matter. And some more sophisticated JavaScript language behavior is happening here called destructuring that we're not going to talk about too much right now. And this is going to look a little magical, but we'll break it down in just a sec. And let's go ahead and let's run this code. We see this printed out. So how did this happen? Let's start with this colors.entries. Let's see what that does. And actually, a great way to do this is if you open up a new shell session and you just type node all by itself, it opens up what's called a REPL, an interactive spot for you to write code. So I will always have one of these open when I'm writing code. So I have my terminal over here to do command line stuff. And when I'm writing code or looking at code and I don't know what this line does, rather than having to like modify this code, I can just really quickly do something like this. And then I can do colors.entries. And if I run it, I see it returns, well, something a little confusing. So maybe this isn't going to be as informative as I thought. It's some sort of object array iterator, which is a little more in depth than I want to go right now. But basically, it's a special object that is meant to be used in a loop. So we're not going to be able to see what happens here. But it returns an array. And in fact, if we call this, let's call this item, and we'll comment this out, and let's console.log item. And let's run this code now. So let me go back over here. Note that what this colors.entries does, right? If we look up here at the array that we're working with, it takes each item and it adds the index for it. Right? And it bundles those up together in their own little arrays. So it builds these 3 arrays or 1 for each item, and I have the index and the item nicely put together. And then if I wanted to, I could do, and in fact, let's, this is a little bit of fancy JavaScript stuff here. This is called syntactic sugar. It's a fancy way to do stuff. Instead of doing this, and grabbing the first and second things or the 0th and the first things from there, I can combine those into one statement. Syntactic sugar is a term for code that does the exact same thing some other code does, but just makes it a little easier to write. And once you get used to JavaScript, this is easier to write because it's one line, and this is called destructuring. And it grabs the 0th thing and assigns it to this variable, and the first thing and it assigns it to that variable. And if I run my code now, we see that working. Right? And if we take this back to the version that we had before here, we see that we're using that destructuring in the for loop. So this is a bit more advanced, and I don't want folks to worry too much because this generally takes some while to get used to. I think I want the big takeaway to be, whenever you've got code that you're like, what the heck does this do? There's almost always a way to simplify it and break it into pieces. And I just want to check in and see if folks have any questions or stuff that we're curious about. Okay, and how are we doing on a scale of like 15 to 20? Is that a 20, Erica? Cool. Alex, I saw a 20. Good deal. Awesome. I appreciate the feedback. And again, we're getting introduced to stuff today. We're going to be writing code like this, week after week. So there's going to be tons of time to practice. Tons of time to practice. Oh, and I see some 19s and 20s in the chat. Perfect. So the Python code works the same way. Instead of entries, Python uses something called an enumerator, right? And so let me just copy this and put it down here just so we can see it. And I'll just type and run this out quickly. I won't go into as much depth, but let's run our Python code. And it runs. And notice that we're doing the same thing, basically, right? Destructuring here. This is basically a little list, right? And we're breaking it into 2 elements. And again, the enumerator is combining, it's creating an index value and it's combining it with a value. And we have a really nice diagram over here kind of showing this transformation, right? Where we have the list with the index values and the enumerator or entries creates a bunch of little lists or arrays that have an index and a value for each one. And remember, I was saying like data is the most important part of code. And again, here we see the more I can play with and manipulate my data, the easier my life becomes. And also, stuff like this lets us avoid that for loop with all of these possibilities to have a syntax error or I screw up my counter or all of this. And this just kind of gets rid of that, right? Unless we really need it. So you can do the same thing to loop through objects or dictionaries. It's a bit different, but a lot of the same principles apply. So in JavaScript, I know we have a bunch of users, but we'll just make another one here. And if I want to loop through the attributes or properties of this object, if I want to transform my object into something else, we can do it a couple ways. And let's see what this one does. Right? And so here I see I'm getting the keys or the properties with this for in loop, right? So I'm just grabbing the keys. So I would still have to do extra work if I wanted to print out the value, right? I'd have to do user, and on an object, you can also use bracket notation, by the way. So I could print that information out. Right? And you can see too how, again, once you start sort of combining or composing these things together, the syntax gets more complex, but it gets more powerful. And we'll see a much easier way to do this in a minute. But then in Python, we have some similar options, right? And in Python, if I have a user that's a dictionary, I can just do for key and user because Python syntax is much nicer and cleaner. Right? And I don't think anyone would argue with that. And even me, who kind of loves JavaScript and has a bit of Stockholm syndrome with it. We can do the same thing to get keys and values. In JavaScript, we use something called object.entries. In Python, we use user.items. So to show that in Python, since I have some Python code up right now, if we do for key value and user.items, and we print key value, or maybe I decide, you know what, I want to do an F string and print them out like this. And maybe I want to add some formatting, you know, just for the heck of it. And if I run my Python code, then we see that stuff printed out, right? Super useful. And in JavaScript, we can do the same. Though, as with all things JavaScript, it is a bit more syntax. JavaScript, by the way, its syntax sort of comes from this language C and this one family of languages, while Python's comes from somewhere else. Though JavaScript has very little to do with C in a lot of ways. And we have to do a little bit of magic with something called object.entries. This is a built-in JavaScript function specifically for getting the keys and values of an object. And I'll break that down, I think, in just a sec. Right? And if I run this code, we see that information printed out. And just to show what object entries does, let's do a console.log of object.entries. And in fact, the VS Code hint here is very useful. It returns an array of key value pairs of the enumerable properties on an object. So we know we're going to get key value pairs in a list or something for each object property that we pass in as an argument. And in fact, we see that we have a nested array here, right? It forms a big array, and then kind of like the other one, we get key and value. So super useful. Those are the main ways to loop. You also have a while loop in JavaScript and in Python. I think I'll just quickly show this example in JavaScript while we're writing JavaScript code. And let me go ahead and comment these lines out. So most of the time I recommend using a for loop because for loops are harder to mess up. The danger with a while loop is a while loop will go on forever until you tell it to stop. So here I'm saying loop for every time you finish the loop, check if count is less than 3. If it is, keep looping, but I'm doing this manually, right? So right now I can run this and it runs fine. But if I make a mistake, if say instead of increasing count, I decrement or decrease count by 1, and this is the same as count equals count minus 1. This is how I decrease a value of a variable by 1. And this is such a common thing that there's a shorthand for it. My while loop is going on forever, right? So this is the danger of while loops. They're really good for user interfaces where like a command line interface where like I type a command that I want to have happen, and then the while loop checks and it prints something. Or maybe if you're playing a game of checkers, right? If you want to deal with each round of the game, you need a while loop, and it's like while no one has won yet, keep playing. But as you can see, if you mess it up, there are consequences. Though it won't be a problem for your computer or anything like that. I'm actually kind of shocked it's running this long and it hasn't thrown me some sort of, usually you get like a stack trace recursion kind of error. So let's talk about functions, and then I think that might be a good time for a break. And I think we're also covering a good amount of the ground here that we want to cover.
So wait, how did you just stop it?
Oh, great question. Thank you so much for asking that. On the command line, whenever you have a process running, and a process is any sort of program that's running, they call it in the foreground. That means you can see it. The keyboard shortcut Control C sends what's called a kill signal to the process, and that'll exit it. So similarly, if I run the Node.js REPL, where I can type like JavaScript code here and stuff, when I want to exit this, I just hit Control C a couple times to kill it and exit. Now, annoyingly, the Python REPL seems to ignore Control C, which I hate, and you have to run the exit function. But for almost everything on the command line, Control C will kill it, and in fact, as you can see, it just produces a new line. Yeah, great question. Thank you so much for asking that. And in fact, let me comment out this while loop before I forget. So functions. Functions are where things start to get fun, because now if I have something I care about, I can bundle this logic up and reuse it. And this is a function definition. My function now has a name. The code inside this, this curly bracket block is the code that runs. When JavaScript reads a file basically top to bottom. When it gets to a function definition, it does not execute and run this code. It's kind of like a variable definition. Somewhere under the hood, JavaScript has done something like this, which is actually valid JavaScript. This will actually work. And in fact, this is called a function statement. I want to say, I can never remember. This is called a named function, and this is, I think it's maybe a function expression. Let's call this greeter2 just for fun. Now, I have defined these functions, but I have not executed and run these. So it's like a blueprint. JavaScript has created the blueprint when it reads these lines of code, but it does not actually execute them. Over here, I can now call my greet function. Let's call it again, and let's call our greeter2 function, and let's call the greet function one more time. And now we see all of these printed out. And let's change this a bit so they look different so we can see what's going on. And let's talk about flow of execution. When my JavaScript program runs, it's going top to bottom, line by line, right? When it gets here, it says, oh, hey, these open and close parentheses like this, I'm executing a function. I better look up the name of this function and find that blueprint. It does. And then the JavaScript code that is being executed, the flow of execution jumps to line 111. Line 112 is executed. We see that print statement here. Every single function has a magic hidden return statement. Every function has to return something, or in JavaScript, it's actually undefined. And in fact, if we did const what greet returns, and we console log it, we will see it should be undefined. And we do. And it's that magic hidden return statement that is how JavaScript knows this function is done. So when JavaScript gets to line 116, it says, okay, cool, I'm creating a variable. What value does it have? Oh, wait a minute. I see I'm calling a function. I don't know what value this variable has. I have to jump over here and execute this function. Let me run this line of code and print this statement. And then, again, we don't need to write that because it's always there. But the return statement tells JavaScript that function is done. And it can return whatever is value there to here. And the flow of execution hops over here, and then it goes here. And then when we go here, it goes back here again, and so on and so forth. And in fact, if I put just a number here, just for the heck of it, we would see that returned. Right? And so flow of execution, I go here, I print this, I return 15. 15 is set to this variable. We print 15. We go here, we call it again. We print this, we return the value 15. 15 is returned here. We don't capture it with the variable. It goes into the void. We go here, we execute this, print this. Again, hidden return statement comes back here, and same thing. If I want to pass an argument to my function, I could do it like this. Right? And in fact, maybe at this point, I decide, you know what? I only want this function to do one job. I want it to construct a greeting message. And I want it to return that message. And I want flexibility and control over what to do with that message. Right? And so we see the same thing happen, but I forgot to pass an argument to greet. And we don't see the last one because it returns this value, but it goes off into the void. And so I want to add a console log, and we'll see one more greet. And now I want to add some names, right? So let's do Alice, and let's do Bob, and let's do Carol. Right. And now I have some reusable code. I have flow of execution. And by the way, I like writing code this way. This code does, if this code, if we passed in a name here, and in fact, let's, I'm going to be lazy and write it like this. Where it's like this sort of combined message, just with plus statements. This function is doing two jobs. It's constructing a message and it's printing it. There's a really important principle in programming called the single responsibility principle. Try to write functions and things that do one job. This is really easy to test and debug, and it gives me flexibility and control, and then have something else do the job of printing that message to the terminal. Especially as programs get big, it'll help you a lot. So I just want to pause and check in here and see if folks have questions or things that we're curious about, especially as I've done a lot of talking here. Okay, cool. And how much of this is review and how much of this is new? Half and half, somewhere in the middle? Cool. And in Python, by the way, of course, the syntax is much nicer. We use def, which is short for like definition or define. So I would say greet. And I could run that. And of course, I forgot to call it. And everything I was talking about flow of execution is true for Python as well. And as you write programs, practice walking through the flow of execution. You need to build up a mental model of how the computer executes your code. I wrote a lot of code and paper in my CS undergrad, and it was a pain in the butt, but they made us do it. And in hindsight, it was really valuable. Right? And if we turn this into what's called a Python f string, we can add our message. Now, Python is a little different. I have an error now. Python is stricter. Remember, its philosophy is there's one right way. Explicit is better than implicit. Because this function now takes an argument, you better pass it an argument. Now, sometimes this can be a pain in Python. So I might want to make a default value for this. And this is now what's called a named argument. And now Python is okay with me doing this. Okay? And you could, in fact, do you can have many arguments in your Python code like this with named arguments and so on. And I just want to see if folks have any questions or stuff that we're curious about here. Okay, cool. We've been going on for a while. We got to dive into function parameters or arguments that we were just talking about, and we saw these examples in action. And this is actually, I think, a really good illustration, right? We have a function is a machine. Remember, I was talking about inputs and outputs, right? We've got logic, we've got data, we've got inputs, we've got outputs. And the beauty of a function is encapsulating logic and code reuse. And I'm hunting around, and here is all of the code we wrote to check if someone is 18 years old in JavaScript. And I'm just going to sort of, actually, let's write it out in Python, because why not? So to show this example, let's say def, person and drink, and we're going to pass in person, and the person is going to be a dictionary. I guess the person didn't need a name for this, but that's okay. And they need has ID. And we say, if the person, if their age is greater than or equal to 21, and in Python we use and, the person has an ID, then they can drink. Right? And now I can do can Bob drink? And indeed he can. And I'm just do a little bit of commenting out of some of that other code so we don't have quite so much stuff printing around. And let's in fact, let's grab another person. There's Alex. Right. So let's create Alex again. Alex does not have their ID. And so in fact, let's have an else return false. because if they don't have their ID, then they can't drink. And so let's make sure this code still works for Bob, and let's test it out for Alex. And we see that this works correctly, right? Alex doesn't have an ID, so he can't drink. If we give Alex an ID, he can now drink. So again, I'm testing my code as I'm going. And let's do Carol. And Carol will be 3. And Carol does have an ID. And let's test this out for Carol. Right? And Carol can't drink either. And I know I left this one a bit simpler than the full implementation, but you can see how you can build this up. You can do all sorts of useful things with this. And in fact, instead of doing it this way, maybe I want to do something like for person in people. Let's print. Let's do an F string. Let's do person get name and drink. And then we'll put right in here. Let's just call our function right there. And let's make sure the print statement is good. Now there's a red squiggly there, and we'll come back to that in just a sec. And now I have an error. Now I in fact have 2 errors. It says name error person can drink is not defined. So let me go ahead and fix that. And in fact, I have another error. It says person can drink is missing an argument. Now this is great because this one line of code is really terse. The downside is debugging can get tricky. So I'm going to maybe break this into 2 parts. And honestly, I usually do this because sometimes you just have to look at the code a different way to help you think about it and debug it. And some people prefer to do it this way because it's more readable. And now it's obvious, right, that the problem is I'm not passing in the person dictionary as an argument. And now I am. Right, so here again, we see how we can really start combining these things. If I start thinking about the shape of my data, how I organize it, it really affects how I write my code. And you can see how, and I'm going to copy these just so we can have this all in one spot. If you look at this code, and Python is particularly great because of its syntax, you can see how if you spend that time thinking about how do I want to organize my universe, it makes your code easier to write. I just want to check in here and see what questions people have, what people are curious about, or what might be good to review or go over.
I had a question. What is the .get doing, and how is that different from using bracket notation or dot notation?
Great question. It does the same. It does the same thing. We absolutely could do bracket notation for a Python dictionary. We can't do dot notation for Python dictionaries because that's a JavaScript thing. And in fact, this is a bit cleaner. And I probably would write this code this way. With dot get, what it lets you do is it lets you pass a default value. If that key name doesn't exist, I could say someone. In this case, though, to be honest, there's no reason we would want that. And in fact, we wouldn't want a default value that would kind of mess up our code, right? Like I kind of want an error if there's not a name here, maybe. So this way probably makes more sense. Does that answer your question?
Yes, thank you.
Yeah, great question. Great question. The .get and the default value will be useful for other stuff. What other questions do folks have? What else are people curious about in terms of this code or anything kind of related to it? And can everyone read it okay in terms of font size and stuff? Cool. How are we feeling? We feeling pretty good?
Yes, got well, not a question, but like a statement. I'm actually about to clock out and try to
Okay.
get real as quick as I can so that I could do stand down. But if everybody didn't see the message, just to let you guys know, I uploaded a it's called Python Basics. It's made by the people who actually run the Python website. I ordered Python Crash Course, the third edition, and I also uploaded the Eloquent JavaScript fourth edition.
That's awesome. Thank you. Yeah, both of those are awesome books, by the way, folks.
So, like I said, I'm gonna try to punch out now, try to get home as soon as I can, so that I can do the breakdown for stand down.
Sounds good.
All right.
Devin, thank you.
Yes,
All
sir.
right, have a good one. Cool. So hopefully you all are seeing, right, the code. We've started with all these simple pieces, but it starts to add up, right, in terms of complexity. And again, it's really about organizing your world. Like if I didn't have my people organized into dictionaries and then my dictionary organized into a list, then this code right here wouldn't be able to be so succinct. So it's really useful. And also, again, breaking the problem into smaller parts, right? And just building it up in little pieces at a time. And now if I need to improve the logic of my person can drink function, it's right here. It's really easy to work on. Its only job is to return true or false, right? And I, in fact, might follow Python best practices and write what's called a docstring, where I say maybe like person, I forget how Python wants you to write it, but it's like this dictionary with person info, and I would say return Boolean, um, true if person can drink. And this is sort of a standard for documenting functions. And notice how if I hover over my function now, the VS Code hint, in fact, uses that. Though I think my format is a little incorrect. So this can be a good habit to get into. I think if you do this, it will also help you think about your code more. All right. I realize we've been going for a bit here. We have a couple other things to cover. There are some shorthand functions that I want to move through briefly, though we won't spend too much time on it. So why don't we take 5, and then when we come back, we'll see some built-in ways of working with functions and making even simpler functions that we can combine in really cool ways. And then we'll have a bit of a break before stand down. Sound good? Awesome. Thank you. And is the walking through the code and kind of talking about it this way in terms of like problems and approaches, is that part useful as well for folks, or is it more like, no, we should just kind of dive through this?
Very helpful.
Okay, awesome. Great. Yeah, again, week 1 is a big week. You all are doing awesome. Get off the screen, take 5. When we come back, we'll see more ways to play around with functions and data. Thank you, everyone, and see you all in 5 minutes. Record. All right. Moving on, shorthand functions. We've seen in JavaScript the long way to write a function. Right? And so if I want to multiply 2 numbers together, now multiply 3 times 2, I'll end up here with 6. Excuse me. There we go. This can be a bit of a pain, right? Especially for short little functions like this. And while we won't see a lot of true functional programming, which is like a whole philosophy where a programming language is really designed around functions manipulating data, we will see this a bit with arrow functions. And the metaphor to think about is, right, a function is a box with an input and an output. And here our multiply function, right, has these two inputs and then it returns that output, right? It's got the input and it's got the output. Well, once you have that input and output, you could feed that right into some other function that also does something with it. And you could do that again and again. And if you think about programming this way, and think of like water flowing through pipes, right? Just water flowing through a series of tubes. And think about data like flowing through your program and flowing through these functions. And it's the exact same metaphor. And this is a very powerful way to program and write code. And we see it in action right here, where this input flows into multiply 2 that returns that output of 6 that we then print. And we could imagine doing even more of this. And in fact, this is sort of I don't want to say a design pattern, but sort of an approach. Called composition, because we're combining and using these different puzzle pieces, these different functions together to get different kinds of programming behavior. And in fact, this is in printing, let's say, number message, right? And maybe this will return a message saying the number is num. And so maybe, in fact, I want to do that like this and say number message and pass that this argument here. And now I've got, again, my data of these numbers 3 and 2 flowing into the multiply 2 function that turns it into 6, right? That passes it into this number message argument that turns it into a string saying what number it is. That passes it into this console log message, printing it out. And I made a mistake because I got my Python and JavaScript mixed up. And the beauty of this compositional approach and this singularity principle, this function has one and only one job. It's super easy to debug. And the beauty of this approach is it's flexible. Let's say I wanted to kind of have different kinds of messages for different situations. And so maybe I have a fancy number message and I say, let's do const, let's see, what's the, what, I can't remember what I'm looking for, but number sign, if the number is less than 0, and we haven't seen this ternary statement, this is a super shorthand. And what this is saying is if num less than 0, return negative, else return positive. And I know this syntax is pretty dense. You don't have to use this. In the interest of time, I'm not going to dive into it too much right now. It's called a ternary, and it's just a one-liner that you can use instead of an if statement. And it's useful for stuff like this because now right in here, I can go like this. And you absolutely could use if else statements in sort of the classic way, so to speak. But once you get used to this approach is quite nice. And so now I could have different kinds of messages. Right? And let's change that 2 to -2. And if I start combining this stuff even more, maybe I want to write a function instead of all this stuff. Maybe I want to write a function and we call it fancy number printer. Or let's call it fancy multiplier, right? I can compose these functions together, Or if I change my mind and I decide I want to bundle them up into one thing, I can do that here. And I need to change this so that this is A and B, and change this so that this is A and B. I apologize. And that's what I was trying to do. And you see this an awful lot in JavaScript, right? So this really is data flowing through a series of tubes, right? I have 3 and 2 flowing into this function, A and B. A gets passed in as an argument right there, right? And then B also passed in as an argument. And then we have that data and it flows from that function into our multiply to function. And all the functions, the multiply ones have to have the same 2 arguments, which we call the signature. And then it changes, right, when it goes to the number message. And then that flows into the console.log. So this is a very powerful way to think about programming. It's very flexible, especially later when we get to React.js, we will see it a lot. Let me just pause here and see what questions people have or things that we are curious about. And how are we doing on a scale of like 33 to 47? Alia, thank you. Good to know. I see a bunch of high numbers there. That's awesome. Great. I'm very glad to hear that. This is one of my favorite parts of programming. Honestly, functional programming is a pretty cool paradigm. We don't go that deep into it, but it's definitely worth going into. And something is up with my keyboard at the moment, and I'm not sure what, but that's okay. So let me comment this stuff out and make sure everything is commented out. So now that I've done all of this talking, let's take this. Oh, this is going to be tricky because I'm used to this sort of Vim mode on my keyboard, and all of a sudden the cursor got messed up. Now that I've done all of this talking, we can now take a look at arrow functions and we can understand why we care about them. Instead of writing that multiply function like this, I could write it like this. And this is called an arrow function in JavaScript. And it's a super shorthand, right? And in fact, then if I wanted to write, let's do fancy, I'm just going to call it fancy message. And this will take a number as an argument. And it will return a string. And this is going to get a little terse, but we will do okay. Num less than 0. This is, I actually would not write code quite this terse in the real world. I try to avoid it, but since we're here, yeah, I'm not going to worry about that part actually, because that's going to be too confusing, but we'll just say the number is num, right? So this is another arrow function and it's returning this. And so now if I want to start using these together, right, I can do console.log, fancy message, multiply 3, 2. So I use them the same way, but they're a lot easier to write and they're a lot shorter. So we'll see in a minute how you can really do some interesting stuff with this with JavaScript. In JavaScript, this is called an arrow function. In Python, interesting. What is going on with? In Python, we call this lambda. And it would look like this. We have to use this special keyword lambda. And so these are the arguments on the left side, and then on the right side, it's A times B. So if I was to write, like to write it the normal way, a traditional sort of function, it would look like this. And to use what's called a lambda function in Python, it looks like that. And we would call it just the same way. So why the heck do we have these things and why do we care about them? There are built-in tools that leverage this. It's called like a functional programming paradigm. And we can combine these with arrow functions. And then all of a sudden, our code starts to become very succinct, very fast. Let's say I have a list of numbers and I want to get just the even numbers. I could write a for loop, but JavaScript has a built-in function called filter. And this does something pretty cool. As an argument, it takes an arrow function. This arrow function takes one argument named n. And then what it's doing is, and I'll put this in, let's write it this way just so it's not too confusing. This modulo is a special operator, the percent sign. It's dividing this number by 2 and giving us the remainder. So 14 divided by 2 is 7 with no remainder. So we would get 0. 15 divided by 2, well, 2 goes in there 7 times, but there's still 1 left over. So it would return 1. So if I divide by modulo 2 and check if there's any remainder or not, I can figure out if a number is even. And in the filter, I actually pass this function as an argument. Note that I'm not calling this function. I'm not executing this function in there. I'm giving the filter function the blueprint for another function. It then does the job of looping through this whole list and creates a new list or array that just has the even numbers. And it would help if I printed out the even numbers. So we could see this code in action. And we see we got the even numbers, right? And if I add a couple more, we'll see that happen again. Right? And look at how little code this is. And you can even write this a bit more succinctly if I wanted to by defining the arrow function right in there. So this is where the syntax starts to get pretty dense, especially when you're not used to this. And, we're basically writing, applied logic, like it's like a math-like syntax at this point. And it looks like I made a mistake because I have the wrong symbol here. And now we have our numbers. But look at how much we're doing in one line of code. I don't have to worry about looping through this array. Filter does that for me. It goes through each one of these. It passes it in as an argument to this arrow function, right? So n equals 1. It checks if n divided by 2 has a remainder. It checks if that's equal to 0. This returns a Boolean. If it's true, filter keeps it in the list. If this arrow function returns false, filter gets rid of it. And the original nums array is still there. It's not modified. Like if we do console.log all nums, we'll see that the original numbers are still there. So I just want to pause and check in here. This is more advanced, and especially in JavaScript, this syntax is a bit gnarly. So I do want to see what's on people's minds. How are we doing? Cool, awesome. This is super powerful. don't worry too much about using this a lot right now. When we get to React, we'll use it all the time. If you do like it though, I do recommend you dive in because it's again a really powerful approach. And you can really start to combine these things in interesting ways. For instance, there is well, I won't get too much into that right now because we will look at maps in just a minute. So let me just show the Python example for this, and then we'll look at sort, and then we'll get to map, and then we'll kind of see how we can combine these things. So in Python, it's the same thing. I have my numbers, and I want the even numbers. I do have to use this special list function in Python because Python uses something called an iteratable. So it becomes a bit denser, and Python has some like extra layers. And in fact, I never quite remember the format for this. I've written tons of JavaScript and just less Python. So the JavaScript I can do with my eyes closed. The Python I always need to look. And so note how this one is a little different, the syntax, right? We have our filter function. We are creating a Lambda function inside here. It's taking one argument named n, which is going to be a number as filter iterates through this list of numbers. We still have the same syntax for the modulo to divide by 2. Because it's Python, we only need to use 2 equal signs instead of the 3 equal signs of JavaScript to do a comparison. But this is still a Lambda function that returns a true or false value, telling me if this number is even or not. We also have to pass in as the second argument to the filter function the nums list, right? So if this is the filter function, and in fact, the function definition here is super helpful that we're seeing here, where we're passing in 2 arguments. The first argument is a function. The second one is a list. Python calls it an iteratable because there's different list-like things that you can loop through, and Python calls those iterables. So that's our first argument, and this is our second argument. And then we have to use this again to turn it back from an iterable into a list, and then we get our even numbers. And in fact, I should print out the even numbers to make sure I don't have any typos in my code. Now, the one downside of all of this is, I was talking about the importance of commenting out code to help debug and things like that. This code is so dense, it's kind of hard to debug it, right? So I think what's really important is if you're going to write code this way, do it in little pieces. And in fact, here we have this error multiply 2, unexpected identifier multiply 2. I don't even know where I'm using it. And it looks like I ran this wrong is what happened. This is just my end of day brain, which I'm sure we all feel at this point. There we go. I was using Node here instead of Python. And so we see our Python list filtering. So there's other useful built-in functional behaviors like this with arrow functions. One in JavaScript is sort. And let me go ahead and just comment out these console logs. So let's say I have nums that are not in order, and I want to sort them. Well, I can call this sort function. Now, sort is a little weird. I need to tell sort how I want to sort things. And so sort is going to look at 2 numbers in this list, and it's going to subtract one from the other to try and figure out which one is bigger or smaller. So sort is a little tricky, I will say. But we see it's here sorted in order. And if I had changed this to a plus, notice how it screws it up and it breaks it. I think because of the negative number and the 0, maybe for other reasons as well. And again, if I need to debug this code, what I do is I grab the arrow function part and I put it into a variable because it helps me look at it better, frankly. If nothing else, it helps me look at it better and see what the heck is going on. And that code should still work just fine. And then if I need to debug this, I have it on one line. I can make sure I have my parentheses lined up, all that good stuff. So again, if you have a complicated line of code that has an error, if you can, try to break one line of code into many lines of code to help you debug. Python, of course, it's way easier to sort because everything is easier in Python. And we can just do, nums equals 31, -15. And I can just do print. Python has a built-in sorting function that makes life way easier. This part here with the map function, and do folks have any questions before I move on? Okay, and thank you for being patient with me. I realize I've ran rather long here. This map function is extremely useful, and this is where stuff starts to get really interesting. So in JavaScript, again, let's make some numbers. Now, let's say I want to double all those numbers. Map loops through every item, just like filter does, but map does not get rid of things. Map changes things. And the thing to think about is by mapping, and this is where TL draw will be our friend. It's sort of some sort of math type term. If I have an array or a list, and the map function, like all of these built-in functions, does not actually modify original array or list. The original data is unchanged. This is actually a big principle in functional programming called immutability. That's a bit too much to get into right now, but is really good to know about. We talk about map because we're taking each of these values from our original array or list, and we're mapping or transforming them to a different set of values in our new array or list. In this case, what the mapping operation does is double everything. So when you hear map, think transform. Like the way that, the real world is there and the map represents the real world, but it ain't the real world. It's like transforming one to another, something along those lines. And so here what we have happen is each of these numbers gets doubled. And if we print our original numbers, and then we print our array of doubled numbers, and let's see where my typo is. Identifier nums has already been declared, no sweat. The beauty of the let statement is once it's declared, I can change its value. And I clearly made a mistake here because I'm looking at the same thing. This is the best kind of mistake, though. Can anyone see what mistake I made in my code in these 3 lines? So this is the best kind of mistake. I make it all the time. It can be the hardest to spot. This code is perfectly great. This code is fine. I just forgot to change this to doubled, right? And the challenge is when you stare at a screen too long, like we are because we had a big day of class and just in programming in general, it's hard for your eyes to see it. So you got to have all these little tricks. And I think of it, the term I use is like an error of assumption. The hardest error to find is the assumption you are making about what is wrong and what is right and where to look. right? So it's important to step back and double check assumptions. And this is where the rubber duck debugging of talking to a friend or a rubber duck or your cat or your dog is actually like a classic programmer debugging tool. Um, there's a reason there is a rubber duck debugging website. So now we see these numbers doubled. Um, what becomes really interesting with this in JavaScript is you can combine these things. You can combine map and filter. And let's say I want doubled less than 7. I want doubled numbers, but I only want doubled numbers less than 7. My syntax is about to get a little funky here, but let's do it. Nums.map, and let's do n times 2, just like we did. Now, the beauty of JavaScript for this kind of stuff, unlike Python, JavaScript is kind of a functional programming language in disguise. It isn't entirely, but it sort of is. So I can use what's called dot notation, what's called method chaining, and now the output of this map statement is going to go into a filter. I'm going to use the variable n again, but I could use y or z, no sweat. I'm going to say if n is less than 7. And let's print this out. And remember that the original nums array is unchanged. So we can really play around with our data. And here we see 2, 4, and 6. Right? So again, data flows through your program like water flows through a series of tubes. And in JavaScript, with this method chaining, you'll often see it written this way. I might want to do another map for some reason. Maybe I want to just add 1 to everything, just for fun. And so this, I think, is also a good visual aid, though, because it helps you kind of see, right? The data nums is passed as an arguments into this dot map that does all its stuff, that builds that new list, right? That does the mapping. Then that output is passed into the next map. And we do more mapping again. And then that output is passed into the filter, right? And this is all done. And once this is all done, it's sent back to the other side of the equal sign and assigned to this variable. And then we get to print it out there. This is pretty advanced, to be totally honest, for JavaScript. This is pretty standard for modern JavaScript, especially with React, but this is not like introductory stuff. You don't start out writing JavaScript code this way. So I just want to emphasize that. I think I want the key thing to be this concept and this idea. So I just want to check in and see what questions folks have and what people are curious about here.
I'm just gonna say, you keep saying it's about to get interesting, and I already think it's very interesting. So I'm like, oh my gosh, how much more interesting can it get?
Awesome. It just keeps getting more and more interesting. I promise you guys. I mean, obviously I'm passionate about this stuff, but this is kind of the fun part, right? Like professionally, to be honest, a lot of professional software engineering is kind of boring. Like good engineering is boring because good engineering is on time, on cost, under budget, reliable, right? That's being a good engineer. But the stuff with programming and computer science is actually really cool. I think. And yeah, there's so much fun stuff to learn. So that really excites me to hear that, and I hope other people feel that way as well. Um, Now, again, when you're writing code and you're doing coding assignments, especially once you hit the assessments, the golden rule is first make it work, then make it better, then make it right, then make it fast. So don't you kind of want to write bad code. Get the bad code to work and then make the code more elegant. I started working with JavaScript professionally in 2014, and most of my career before coming to Code Platoon was JavaScript. So I've been doing this a long time, and depending on how much you all have done before or not, some of this will come easily, some of it'll come more in time. But yeah, that's awesome. No, that really makes me stoked that you find it exciting. The Python version of a map, they call it a list comprehension. This is a great example of like sort of the philosophical difference between the two languages and how they're sort of for different things. Like the way this language is designed, it kind of lends itself to like a functional programming style, as you can see. Like if you think about data flowing through a series of tubes here, it works rather well. Python wasn't really designed that way, though it does similar stuff. And so in Python, what we do is they call it a list comprehension. Um, and sorry, let me just get rid of these lines. And let me just I know I keep making the same numbers again, but that's okay. And so to double numbers in Python, instead of this map, we use what's called a list comprehension. And it's kind of like we're building a new list, but the logic to build the list, we put inside the list. And it looks like this, which is also really cool and quite elegant in its own way, but you can see it's kind of a different approach, right? You can't kind of like chain this stuff together quite the same way. But it's great because it's super effective and succinct and simple. And there we see the list comprehension in action. And I mean, you can do stuff with like filter and lambda to chain things, but that's really like this is what JavaScript does really well. Python does other things really well. And some of it is just about syntax and style. So and with JavaScript in particular, this is a big part of why it's used a lot in like user interfaces and some other things. So we've learned a little bit about functional programming along the way, right? I think the big innovation is this idea of a program is data flowing through a series of tubes. I really think if you can like start thinking of your code that way, then life becomes easier, right? You can work on smaller pieces of it. You can break it into smaller parts. It becomes easier to debug. It becomes easier to fix. You don't have to figure the whole thing out at once. And it doesn't matter if you're working in Python or JavaScript, the metaphor still works really well. Because any program everywhere is to go all the way back to the README from the beginning of class today. And let me go ahead and close these out since we're wrapping up our lesson. Coding is the least important part of programming and software engineering, but it's the most important, right? We get to be creative. We get to think about how to take a real world problem and create a universe in a computer to model it. We get to use software to do this. We get to think about the domain or the problem. We get to think about what's in scope and out of scope. And a program is data, logic, input, and output, right? And if you can start when you have coding problems and things to work on, if you start thinking about stuff that way, and those, like if I'm doing a technical interview and I'm applying to a job and they give me the problem, those are the questions I'm asking. Oh, you want me to sort a list of users? Great. How many users? 10 users, 1,000 users, 10,000 users? What's the data look like? Is it a text file of CSV data? Is it, arrays in Python? What sort of information do I have about my users? Are they first name? Are they last name? How clean is the data? Like, does every user always have a first and last name, or are there some blanks? And if you just start practicing asking questions about inputs and outputs now, and you think about how you want to organize your data, then the logic starts to take care of itself. So I think that's a great stopping point, especially since it's 5 o'clock Central. Let me go ahead and stop our recording and we'll do our plan for stand down. And so just to conclude, by learning these ideas in both Python and JavaScript, you build up problem solving skills that will help for your entire career. no matter what languages or technologies you work with. And as you master one, you'll see it show up in other places in different ways. Awesome, folks, and thank you very much.